grabbed it yet. We're going to take some notes. We are talking about exponents. How would you define exponents in an easy way? In a simple way, how would you explain what exponents mean? You multiply, so 3 to the 4th power is 3 times 4?
Well, no, multiply it that many times.
Yeah, exactly. It's repeated multiplication. Repeated multiplication. Good. So if I have this, first of all, how do I say that? 6 cubed, 6 to the power of 3, 6 raised to the 3rd power, right? Those are all true. What I don't want to hear is 6 3, 6 thirds, 3 over 6, 6 over 3. No. 6 to the 3rd power, 6 cubed, 6 raised to the 3rd. No. No. And what does 6 to the 3rd power, what does that mean? Yes, 6 times 6 times 6. Perfect. And what do we call the 6? The base. And what do we call the 3? Yeah, just the exponent. That's easy. Okay. And so these are kind of like 2 different forms, and we talked about these 2 forms on Tuesday. What do we call each of these forms? Yeah, this one is expanded form. And then what do we call this? Exponential form. It just has the exponent. Good. And let's write down our properties. So we talked about 3 properties on Tuesday. We talked about multiplication. That was one of them. Multiplication. And what do we do when we're multiplying with exponents? If I have the same base, what can I do? If I'm multiplying with exponents and I have the same base, what do I do with? You add the exponents together, so that becomes b to the n plus n, right? B, the base stays the same. So like this, if I have 2 cubed times 2 to the 4th, what does that equal? Not to the 8th. 2 to the 7th. 2 to the 7th, right? 3 plus 4 gives us 7. Base stays the same. Then we have power to a power. So usually we'll see parentheses for this, right? I have b to the m, I have a base raised to an exponent, and that is raised to another exponent. What do I do when I have a power raised to a power? Yeah, you multiply the exponents, right? So if I have x to the 6th raised to the 3rd power, what do I end up with? X to the 6th raised to the 3rd? X to the 18th, good. Okay, and then what was the 3rd property we learned about? Division. So if I have division, same base, what do I do with my exponents? Yeah, and the base stays the same. So if I have something like this, p squared over p squared divided by p, what do I end up with? Well, first of all, this p in the denominator doesn't look like it has an exponent. So what invisible exponent does it have? Yeah. So then my base stays the same, so it's still going to be p. And what's the exponent going to be? Yeah, 1, right? 2 minus 1 gives me 1. Perfect. Okay, we have 2 more properties to learn. And there's a harder one and an easier one. Which one do you want to learn first?
Hard. Start with the hard.
Okay. Negative exponents. So when we have a negative exponent, 2 things happen. We move the base to the opposite place, and the exponent becomes the opposite sign. So b to the negative n equals 1 over b to the n, and 1 over b to the negative n equals b to the n. It's just kind of weird. And let me just kind of explain this just a little bit more. So I can write any number I want. You don't need to write this down, just watch. Any number I want, I can write it as a fraction, can I? How do I write 3 as a fraction? Yeah, just over 1, right? 4 over 1, 5 over 1, 6 over 1. Even if I have x, I could write that as a fraction. That's x over 1, right? So that means every single number has a numerator and a denominator, right? So when I have a negative exponent, it moves, if the base starts in the numerator, it gets moved to the denominator. If the base starts in the denominator, it gets moved to the numerator. So it moves location. I like picture them in like a house, and it's like moves from upstairs to downstairs or downstairs to upstairs. So it just moves the location and flips the sign. So it goes from negative to a positive. So let me just show you a couple examples. I'm going to erase this stuff. So if I have 1 over 2 to the negative 4, what's that going to equal? Yes, 2 to the 4th. Okay, and if I have 3 to the negative 8th, what's that going to become?
1 over 3 to the 8th.
Perfect. That's exactly it. Okay, it's not that bad. It's just kind of weird. It's just like kind of hard to explain, I think. I think once you see the pattern, it makes sense. Okay, so there's our negative exponents, and then the easy property is our 0 property. Any base raised to the 0 power equals 1. Yes, not 0, 1. Okay. So if I have 2 to the 0, that equals 1. 3 to the 0 equals 1. 0 to the 0 equals 1. X to the 0 equals 1. Anything raised to the 0, x cubed, y squared, z to the 8th power, all raised to the 0, it's 1. Pi raised to the 0 is 1. I raised to the 0 is 1. E raised to the 0 is 1. Anything raised to the 0 is always, 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 always 1. Okay? I think about it like this, like if I have 3 cubed over 3 cubed, right? So what do I do when I'm dividing with exponents? I subtract, right? So that would become 3 to the 0, right? And I know 3 cubed is 27, and 3 cubed is 27, and 27 over 27 is 1. So that is kind of like a reasoning. I want to think of a better explanation. I'll look into that over the weekend and tell you on Monday. Because that proves why it's 1, but it's like, I don't know, sometimes, math is like very faith-based. Like you don't really have a reason why, you just kind of trust it. And I'd like to provide you with a little bit more of a reason, huh? Like imaginary numbers, yeah. and like, I don't know, the quadratic formula. What is it?
Yeah.
So x equals negative b, add or subtract the square root of, I didn't sing it, so I don't know. I can't sing. X equals negative b, add or subtract square root quantity, b squared minus 4ac divided all by 2a. That's how you use it to solve. So these are called parabolas, these kind of lines. And this will give you two numbers. It'll give you the positive and the negative.
Okay.
And that tells you where the x-intercepts are.
Do we learn this in this class?
Maybe this class will get to it by the end of the year. You definitely do it in algebra too.
Oh, okay.
I haven't taught it yet because, but you guys are quick.
Do you have a
What did you, push pin?
Yeah.
In that top drawer, if you just open that up, it'll be in there.
Just yeah.
Okay. Okay, what do we think like common mistakes are for exponents? Really easy mistakes to make. Yeah, that one comes up all the time, right? 6 to the power of 3 does not mean 6 times 3. 6 to the power of 3 means 6 times 6 times 6. What else? Any other kinds of like mistakes you think are easy to make or things that are kind of confusing? Yeah, a lot of times people will think something to the 0 equals 0, but that's not true. Anything to the 0 is 1. Yeah. Or like this. What's wrong?
5 minus 6 and negative 1. It needs to be 6 minus 5.
Yeah, it should be 6 minus 5 instead of 5 minus 6. It's always numerator minus denominator, so that's not true. It's x to the 6 minus 5, which is x to the first. I was also seeing this the other day. What's wrong with that? Yeah, you got to keep the base the same, right? Those 7s don't cancel out to be 1. They stay, it stays there, and the exponent just changes. And then something else to just remember, right? What is the exponent on that? Even though we don't see an exponent? Yeah, it's 1, right? Cool? Okay. So what I want to do now is some whiteboard practice with you. So you can just keep this to the side.